Okay, so this is 4.1.2 scale drawings. Let's go ahead and title it on the top left corner of the next page in our composition notebook. So we're on the left-hand side of our graphing composition notebook. Go ahead and put 4.1.2. This is scale drawings. Okay. So here's our intro. Maps are examples of scale drawings. They're reduced versions of the original regions, right? So they're reduced versions of the original regions. A map is similar to the original region because it has the same shape. So if you look at a map, if you like Google any map, the look of and the shape of California should look like where the borders and the shape of California is, right? Because of this, maps conveniently allow users to determine the distance between 2 points, right? Before, when we actually had like paper maps and not like Google Maps or anything like that, we had to figure out how far it was to be able to calculate like how long it would take us to get there. In a scale drawing, it is important to decide on the unit of measure. Maps made in the United States usually represent distance in miles, right? But they certainly cannot use actual miles as the unit of measure. Otherwise, a map of Pennsylvania would be over 250 miles long and 450 miles wide. And that would be a ginormous map, and nobody could read it because you can't even see that far. A map includes a scale which shows the units in which the map is drawn. An example is shown at the right. So here is the example of the scale. It's saying that 1 inch on the map represents 5 miles in real life, right? So if you have an iPhone, I only have an iPhone, so that's the only thing I can reference. I don't know about Android users or students. If you don't have phones, then I think Google Maps on your Chromebook has it as well. But basically, if you zoom in and out on Google Maps, it has a scale on the bottom right-hand corner, and it shows you like if it's this much, this represents however many miles or kilometers it is, right? And it's useful because before I would be like, okay, this is kind of like an inch, right? And then I would measure on the map. I'd be like, okay, this is 5 miles, this is 5 miles, this is 5 miles, this is 5 miles, and I could figure out how far it was apart. Okay, so 4-11, I just want you to answer an Ed puzzle. Suppose Eulalia uses a map of Pennsylvania to determine that Valley Forge is 14 miles from downtown Philadelphia, right? Did she really measure 14 miles? So the first question is, did she really measure 14 miles? And the second part is, explain how you think she probably determined the distance. This is just your opinion. 4-12, I'm actually going to modify it. So let me go ahead and do this because I want you to be able to know the process of it before we get into more complicated numbers. So let's go ahead and put 4-12, right? And I want to have you guys sketch this in your notebook. Now, it doesn't have to be a specific size because this is our not to scale drawing, not to scale. Right? A lot of times when you see things, if you see like packaging, if you look at like cookies, right, or cereal or something like that, it'll always say image not drawn to scale. Because if you actually open the cereal or if you actually open the cookies, it's not as big as the picture, right? Lots of times very disappointing. So that's what it means as it's not drawn to scale, right? Or image or actual size not drawn or something like that. Right, so we're going to draw the not to scale version and go ahead and draw this with me. So we're going to go ahead and skip a couple lines, go down, and we're going to draw this L shape here, right? Again, not to scale. And then what I want you to do is just kind of draw a border around it. Right? And we're going to label this. So some I keep, some I don't. This is 100. And that one little tick mark right there, that tick mark right there means feet, right? So 100 feet. We've got 56 feet at the top, right? So this is actually going to be the word problem right here. And then the other pieces that are given is this is going to be 40 feet. This one right here is going to be 32 feet, right? This one right here is going to be 24 feet. The one going across is going to be 16 feet. And then the last piece right here, this is 8 feet, I believe. Right, let me make sure that I got all of what was written on this. Perfect. Okay. So here is my garage. And then what we're going to do, right? What we're going to do is we have to be able to sketch it to scale. What that means is like what it looks like on the paper that we draw. If I enlarge it perfectly, proportionally, then it will look like what it looks like in real life, right? So if you've ever seen like Barbie dolls and the what's it called? The drama behind Barbies is that Barbies, if you made it into a real life human, it would look really unproportional. Like it would look really messed up and have like their arms would be way too long and their, I don't know, some other parts and stuff like that. So it's not realistic, right? What it means is if you enlarge a Barbie like proportionally, the eyes, the head, the shoulders, all of it at the same rate, then it would not look like a human being, right? And then that's the whole drama behind it is like Barbie, the image of it is like a lot of people are trying to fit that image, but it's not a real image, right? It's not real. Okay, so let's go ahead and replace this. Guillermo needs just a scale drawing of his house placed on its suburban lot. This lot is 56 feet wide, so we labeled that, 100 feet deep. The garage is 20 feet back from the street. So let's actually go label that. So the garage from here, the street, this is the street. This is also 20 feet. Okay. So he says he has a sketch of his house, not drawn to scale. This is not to scale, with the measurements shown at the right. So it says use a graph paper and ruler to create a scale drawing of Guillermo's house on its lot. Now, I don't know if all of you have rulers, so we're just going to use our graph paper to be able to do it, right? And in order to do that, we need to draw our scale. We need to determine what our scale is going to be, right? You can say that one box represents 1 foot, but then you would literally have to draw 56 boxes across and 100 boxes down. And your notebooks, I don't think they have that many boxes. So we need something bigger. They're all even numbers, so you could use 2, but 50 boxes, right? 50 boxes for 100 feet would also be too long. So I'm going to give you the scale. This is our scale, right? And our scale is going to be one box is equal to 8 feet. What that means is I have to convert every single one of these and then be able to figure out how many boxes I need to draw for this, right? So let's go ahead and do this. One box equals 8, which means 8 feet equals one box, right? And I'm going to create this table of measurements, right? If I have 100 feet and I'm keeping it proportional, right? If I do this, right, the same thing every single time, how do I go from 8 to 1? What am I going to do? I'm going to divide by 8. So I need to do that for every single one of them. 100 divided by 8, right? 100 divided by 8, let me just double check, is 12 and a half boxes, right? Let's keep going. 456 feet, right? If I divide it by 8, keeping this same ratio, I'm going to get 7 boxes, right? And then the other numbers are a little bit smaller, so I can do that. The only other one that I want to do is 20 feet, right? From the street to the garage. And if I did 20 divided by 8, this will give me 2.5 feet, 2.5 boxes, sorry, right? And I'm going to measure everything else, right? And so I can continue doing that for all of them, but I can do the rest of them kind of in my head. So we're going to go ahead and draw, right? So the first thing I need to draw is that outline of the box, right? 56 across will give me 7 boxes across. So I'm going to go ahead and draw 2, 4, 6, 7. There are 7 boxes. And I was off on my other one. Going down, this is 12 and a half boxes. So let's go down 2, 4, 6, 8, 10, 11, 12, and then half. Okay, and I'm going to complete my rectangle, right? So I'm going to go ahead and draw this down. And then draw that line where it is halfway cutting across all the boxes, right? So this one is drawn to scale. And notice already my picture, my actual thing that's happening for the scale is much different than the one that was not to scale, right? It's much longer, okay? Okay, continuing on. So moving from, this is my I want you to note that this is 8 feet each, right? So this is 8, 8. This is going to be 16. This is going to be 24. This is going to be 32. This is going to be 40. This is going to be 48. And the next one is 56. So we know our measurement is correct, right? Each box represents 8. 8 plus 8 is 16. 8 plus 8 more is 24, and so on. Okay. From the street, we're going up 20 feet. 20 feet is 2.5 boxes. So that means I'm going up right here to that point right there, right? And the other piece that I need to know, because I need multiple directions on where I need to draw my things. The side right here, this is 8 feet. So I know that I'm going in one box, right? So I'm going to go in one box. This is my 8 feet. And I start drawing my house. House, his house, Guillermo's house, right? Now I can do it a little bit quicker. 16 feet. So this is my 20 feet, which equals 2.5 boxes. This is my 20 feet. This is my 8 feet, right? And I'm going to go ahead and draw the rest. So 16 feet, 16 divided by 8 will give me 2 boxes, right? Going up from there, 24 feet divided by 8 will give me 3 boxes. So here is where my house is. This is the garage, right? Going to the left, I don't know what this is, but what I can look at is 40 feet is this whole thing, right? Let me go here. If this whole thing is 40 and this little piece right here is 16, then I can figure out the rest. This piece right here is 40 minus 16, right? Can't think. And this will give me 24, right, as well, okay? So 24 feet right there divided by 8 will give me 3 boxes. Right? And then I'm going to go up. 32 divided by 8 will give me 4 boxes. So I'm going to go up. Right? Going across 40 feet divided by 8 will give me 5 boxes. So I'm going to go across 5 boxes. And then I'm going to go down the rest, right? Which is what it told me. Okay. So we're creating the scale drawing. We created the scale. The scale is very important. When you draw something, when you have anything that's written, the scale is very important, right? So 1 box equals 8 feet, which means I know that this is 1 box. I know this is 8 feet. This is 8 feet, so it's 16. This is 8 feet. This is 8 feet. This is 8 feet, so it's 24, right? Okay. So there is what our house looks like. This is what the drawing should have looked like instead of this more square shape up here, right? Then it says for part B, Guillermo wants to put a rectangular swimming pool in his backyard, right? So let's go ahead and label these, right? This is 56 feet. This is 56 feet. This is 100 feet. This is 24 feet. This is 24 feet. This is 32 feet, 40 feet. And oh, we can add those together. So 56, this is 56 as well. Nice. Okay. This is based, again, this different from the book. I modified it so we could divide and have everything pretty nice besides that little halves. Okay. So the question is, Guillermo wants to put a rectangular swimming pool in his backyard. What is the largest pool you would advise him to have installed? Right. And this is on you guys. I want you guys to ask. Let's go ahead and make this is the garage. I would say most garages are in the front of the house. So we're going to go ahead and make this part the back of the house and the pool is here, right? So you tell me, right, the dimensions of what your pool would be, right? How long would it be? How wide would it be? And then let's go ahead and double check your work. So if this is 40 inches, right, 40 feet, sorry, 40 feet, this right here, this right here is 8 feet. This right here is 8 feet, right? And going up, I need a measure right here. So this is 20, right? This right here is 56. And I know that the whole thing, because on the other side, the whole thing is 100. So if I take 100 minus 56 minus the 20, that means that what I have left here would be 24 feet. So the maximum, I don't know what you guys did, but the maximum it could be is 56 feet by 24 feet. And that is if you literally open your back door and step into a pool. There's like no room to have chairs or anything like that. It's literally fence, water, right? So your dimensions should be smaller than that. Right? But it depends however you want to be a construction worker. Okay, here we go. Next one. A scale drawing at the right shows the first floor of a house. The actual dimensions of the garage are 20 feet by 25 feet. Okay, so let's go ahead and draw this in our notebook. And this is 4-13. Okay, 4-13. And this is going to be 2 inches. So since this is a little bit smaller, I'm going to actually draw it a little bigger. So I'm going to draw 4 boxes. Right. And then this one is 1 1/4 inch. So I'm going to go 2 boxes for the garage. 1 1/4 inch would be 2.5 going down. I just doubled it, right? So 2 inches, 4 boxes, 1 inch, 2 boxes, 1 1/4, and so on. And then the bottom ones we don't know. So let's go ahead and draw a little bit more. And then we're going to go ahead and draw this in. Oh, the office is there too. So the office needs to stick out a little bit more. This is the office. We've got the garage. We've got the living room. This is 2 inches. This is 1 inch. This is 1 1/4 inch. And then we've got the kitchen and the dining room. So kitchen, dining room. Okay, so this is the first floor. It says how many feet, right? So the actual dimensions of the garage, and we're looking at the garage here, right? It says how many feet does each inch represent, right? And it says the actual dimensions of the garage are 20 feet by 25 feet. Now you got to think which one matches which one, right? Is it 25 feet or is this 25 feet? And the way you think of it is 25 is bigger, 1 1/4 inch is bigger. So those are the ones that match up, which means this one equals 20 feet. This one equals 25 feet. All right. Just by the information that they gave us, right? So it says, what is the length and the width of the living room on the scale drawing in inches, right? So the length, if I look at this, so let's write A, have all our answers. A, how many feet does each inch represent? So 20 feet equals 1 inch. This is our scale, right? Usually it works with 1 feet, 1 foot, 1 mile, 1 something is equal to something else. Okay, so that's the scale. For B, what's the length and the width of the living room on the scale drawing? So if I look at B right here, going across, this is 2 inches, right? So 2 inches, this is 2 inches by, and the width is, I'm using the same one as the garage. This is 1 1/4 inch, 1 1/4 inch, right? This is the living room. Okay. What is the actual length and width of the living room in feet? Now, if I look at this, 20 feet is 1 inch, right? Which means that each inch, and I'm going to work backwards, each inch, 1 inch is 20 feet, right? So what do? I multiply it by 20. I use the same thing that we did in the other problem. So if it's 2 inches, 2 inches, I'm going to multiply it again by 20 and I will get 40 feet, right? If I have 1 1/4 inches, right, and I multiply it by 20, and the way that I actually like to think of this is 1 inch is 20 feet. So this 1/4 inch right here has to be the 5 feet, right? Which means I would have 25 feet, or it's already written there, right? So this is 25 feet, right? And this is now 1/4 inch is 5 feet based off of the diagram. Or you could multiply it still by 20. Okay. Then it says, if the family wants to lay carpet in the living room, carpeting costs $1.25 per square foot. How much will the carpet cost? There's two parts to this. Okay. So the first part is it says per square foot. Square foot means area, right? So let's go ahead and write this down. If I put D, it says $1.25 per square foot, right? So we need to find the area. If my living room, if I have this rectangle right here, is, and I look at this, it's 40 feet by 25 feet. So 40 feet by 25 feet. And I find the area, then I would do 40 feet times 25 feet. And this will give me 40 times 25. This will give me 1,000 square feet. Okay, so this is what I'm looking at, right? And then if it's $1.25 per square foot, that means for each one. So 1 square foot is $1.25, 2 square feet is another $1.25, and so we're multiplying it. Usually when you see the word per or each or for every, right? When you go to the grocery store, it's like per pound, right? For every apple that you buy, it's this cost. And then you just multiply it by how many you have. So I will take my $1.25, right, per square foot, and I multiply it by 1,000 square feet, right? When I do this times 125, I will get $1,250 for that cost. Okay, and the way I look at this, for units, this is chemistry when we did this too. My units cross out too, right? Simplify, top and bottom. I'm left with dollars. Okay, here we go. I think we're going to end there. I do want you guys to look at maps a little bit more, but we'll get that because you guys don't have a ruler. So I might have this as a bonus problem later. Okay, that's it. Make sure you get to the end of the video, upload any pictures that you need to, and that is it for this section. Thank you.